Have you ever walked through a bustling city or maybe just driven through a new suburban development and, stopped to wonder who actually made this happen?
Hmm.
It's rarely the architect, the one who drew the nice pictures, or the contractor you see in the hard hat laying bricks.
Yeah, that's true.
More often, it's this specific figure who takes the initial and, let's be honest, greatest risks.
Yeah, absolutely.
The person who looks at a patch of dirt, basically, and envisions a vibrant community or maybe a thriving office complex or just a cozy new neighborhood.
It's true. Every single building we interact with, every park we might stroll through, every shopping center that shapes our daily lives, they all have a starting point, a genesis.
Right.
Usually it's a visionary entrepreneur who didn't just sort of react to what the market needed, but actively went out, saw an opportunity, pulled the pieces together,
Yeah.
and set this incredibly complex, multi-layered machine in motion. They really are, in essence, the ultimate client in the huge, intricate world of construction.
And that, dear listener, is exactly our mission today. We're embarking on a deep dive into this fascinating, sometimes pretty high-stakes world of the real estate developer. Our goal isn't just to define what they do, like a job description. We want to really extract the crucial insights into their unique mindset, their core motivations, and the typical, often, labyrinthine process they navigate.
It really can be.
From that very first glimmer of identifying a gap in the market all the way through to seeing a tangible vision actually rise from the ground.
Yeah.
And understanding this perspective is, honestly, without exaggeration, a critical best practice for any architect, any contractor, urban planner, or even just a curious citizen who wants to truly thrive or maybe just make sense of our built environment. Okay, let's unpack this.
Let's do it.
So let's really dig into who this developer is at their core. We've kind of hinted at it, but it's way more than just a job title, isn't it?
Oh, absolutely.
They are the quintessential entrepreneur in the built world, the person who first spots a void or an opportunity in the market.
That's the key identifying opportunity.
Yeah, it's not simply about having an urge to build something. It's about responding to a deeply perceived need, whether that's for more affordable housing or cutting-edge shops or, flexible office spaces.
And this is a really crucial distinction, actually. It sets the modern developer miles apart from builders of the past.
How so?
Well, think about some of history's most iconic structures. The great medieval cathedrals, for instance.
Okay.
Abbot Suger's amazing work at Saint-Denis, the Royal Abbey, where French kings were buried. That was born not out of market demand, right?
Oh, definitely not.
It came from profound religious faith, from royal patronage, or think about the sheer artistic and ecclesiastical ambition behind St. Peter's Basilica in Rome. That place fascinated geniuses like Brunelleschi and Michelangelo.
Driven by faith, power.
Exactly. These were structures driven by spiritual devotion, political power, or just sheer public display. Very different motivators.
So a completely different impulse, really. Not about ROI or market share, but divine inspiration or demonstrating might.
Precisely. Today's developer operates almost exclusively within an economic landscape. As the legendary management thinker Peter Drucker observed, they're aiming to produce revenue, to create markets, and to change the economic characteristics of existing products and markets.
That's a very business-focused view.
It is. The fundamental question driving them is always, which products really produce extraordinary economic results or are capable of producing them? It's not just about building. It's about economic alchemy almost, transforming potential into tangible, measurable value.
That's a huge shift, isn't it? A really profound shift from, like you said, divine inspiration or a king's decree to this very grounded, market-driven search for value and economic viability. And that search, that quest, it speaks volumes about the developer's unique position. They are, without question, the ones taking on the initial and greatest risk.
Unequivocally.
They're putting their skin in the game, their own capital, their reputation, their time right from the very start, assembling all the diverse resources needed to chase that market opportunity they've spotted. It's not just a job. It's a massive, high-stakes entrepreneurial gamble, really.
It truly is. If you think about it conceptually, like the project management body of knowledge, the PMBOK guide describes it, the developer effectively builds a whole project management system.
Okay.
It's made of interactive, interrelated, and interdependent management capabilities that work in unison to achieve desired project outcomes. Think of it like a master conductor leading a hugely complex orchestra.
That's a great analogy.
And their core objective through this whole orchestration is always to maximize value, manage constraints, and improve performance.
Maximize value, manage constraints, improve performance.
Got it. And this entrepreneurial drive, it demands a particular kind of foresight and, crucially, a brutal realism.
Realism, huh?
Yeah, it reminds me of how George Washington was praised for his salient strength of seeing things as they were and not as he would wish them to be.
Ah, that's interesting. So no rose-tinted glasses.
Exactly. That ability to assess market realities without bias, to understand the cold, hard facts of the land, the budget, the actual demand is absolutely critical for a developer. You have to be grounded in the actual conditions, not just the hopeful ones. Because hope doesn't pay for steel and concrete.
No, I suppose it doesn't. That makes a lot of sense. Okay, so with that foundation, understanding the developer's role as this risk-taking orchestrator, let's walk through how they actually turn that initial spark, that idea, into a real, tangible, maybe revenue-generating building.
Right, the process itself.
The journey really begins with site selection and that initial visioning, doesn't it?
Absolutely. And it's not just about picking any old empty plot of land. That's a common misconception. It involves a really complex assessment of a site's potential, its limitations, and crucially, how a future building will interact with, maybe even transform, its surroundings. The context is everything.
Context is key.
Precisely. You know, the wisdom here is ancient. Even Andrea Palladio, the famous Renaissance architect, recognized this interplay centuries ago.
Palladio, okay.
Yeah, when he was discussing grand facades, these big tripartite ones, with a central focus, he noted they cannot be effective without some open space before it. It would not work in a narrow city street.
Ah, so the building needs its stage.
Exactly. He understood that a building's design was intrinsically linked to its context. Today, that pre-design phase involves a super thorough review of design concepts and studies, potential external challenges or deterrents to the project, funding, schedule, and community impact.
Wow, it's a lot up front.
It is. And it's not a solo act, it's highly collaborative. It brings together all the key players. The developer, the eventual owner who might be the developer or an investor group, and the designers. Everyone's involved early.
That interaction with the environment, whether it's natural or urban, that's really fascinating. You can look back at how ancient Roman cities, like Timgad,
Grid plan.
yeah, laid out with that rigid orthogonal grid, a very deliberate, almost imperial stamp on the landscape. Or, completely differently, you look at the terraced architecture of Hatshepsut's temple at Deir el-Bar,
Incredible sight.
which was literally welded to the rock landscape, responding with amazing sensitivity to its natural setting.
Yeah.
Today's developer kind of has to grapple with that same tension, right? How much do they impose their vision versus how much do they have to respond to what the land and the community are telling them?
That's a fantastic observation. It really highlights that age-old dance between, imposing a vision and responding to the land's inherent character, its genius loci.
Right.
Today, developers face that same dilemma, but maybe with even more complex variables, intricate environmental rules, existing infrastructure you have to tie into, community expectations.
Oh, definitely community expectations.
Big time. And it's after wrestling with those initial visioning questions that they move into the really granular, often painstaking phase. Due diligence.
Due diligence sounds serious.
It is. This is where the developer basically puts on their detective hat. It's not a quick glance. It's a deep, almost forensic investigation into every single facet of the project. You leave no stone unturned. Imagine peeling back layers of earth, history, bureaucracy.
Okay, so due diligence sounds incredibly thorough, almost daunting. What's maybe the one aspect of it that, if you overlook it, could spell absolute disaster for a developer? And maybe what's a surprising thing they might uncover?
Good question. The biggest disaster often stems from overlooking environmental or geological issues.
The ground itself.
Exactly. You need comprehensive environmental and geological assessments. This is about understanding the structure of a system, as systems thinking teaches us, to predict its behavior. If the land has hidden holes in the bucket, like unforeseen soil contamination or unstable geology, those issues can completely derail the project, rack up massive unforeseen costs, or even make the site totally unusable. Disaster.
Wow.
Historically, builders were intensely aware of local conditions because, well, they had to be.
Right. They worked with what was there.
Precisely.
Hmm.
In England, for example, the availability of different building stones, limestone, slate from Skiddaw, flint, and chalky areas, it directly dictated construction styles.
Mm.
Builders didn't just choose materials, they responded to what the earth provided.
Makes sense.
Even Roman lead-silver miners in Britain, they drove these clever, tapering tunnels into the hills just to get a natural draft for their furnaces.
Yeah.
That shows a deep, practical grasp of geology and engineering.
Fascinating.
And for foundations today, the specifics are critical. Wall thickness, height, how much rebar, the backfill height, the soil type. For instance, walls on really extremely stable soil may be center, sometimes only 6 inches, and need less rebar. That saves money.
But get it wrong.
Get it wrong, and you're looking at structural failure. Big problems.
That's a powerful example of the real-world stakes. So knowing what you're literally building on is fundamental. But it's not just the physical ground, is it? There's also that tangled web of rules and regulations.
Oh, absolutely. Beyond the physical site, regulatory scrutiny is paramount. This involves a deep dive into zoning and entitlements.
The labyrinth.
That's a good word for it.
Yeah.
It's often a labyrinth of local, state, even national regulations. These dictate precisely what can be built, where it can be built, and how. Can you put residential units here? How tall can the building be? What's the maximum density?
So many questions.
Exactly. Navigating these rules is often as complex as the engineering itself. It requires immense patience, legal expertise, and usually a network of experienced consultants. Miss one single zoning requirement, and your entire project could be dead in the water or face years of costly delays.
Yikes. Okay, so once all that really rigorous due diligence is finally done, and the developer has a clear, probably quite sobering picture of the site and its constraints, then the vision starts to take real shape through design. And this requires something really important: collaboration and technology. The developer has to build the team of designers and contractors to actually materialize their concept.
Exactly. This is where the abstract ideas begin to become tangible forms, actual shapes and spaces. The design process typically moves through distinct stages.
Okay, what are they?
First, you have schematic design. This is where the designer takes the owner's needs, the site realities, and synthesizes them into an approximate form. Early sketches, diagrams, basic 3D massing models.
Getting the basic idea down.
Right. Then comes design development, where you refine those dimensions, materials, building systems with much greater precision, more detail.
Okay.
And finally, construction drawings. These are the incredibly detailed plans, specifications, schedules, everything needed for permits, for bidding, for contracts. These are the actual blueprints for building.
The instruction manual.
Pretty much.
Yeah.
And modern developers heavily leverage building information modeling, or BIM.
BIM, right. We hear that acronym a lot.
And for good reason. It's not just fancy 3D modeling, though it does that. It's really a digital database in which objects, spaces, and facility characteristics are defined and stored.
A database, okay.
Yeah. BIM tools allow for parametric objects. That means if you change one element, say the width of a window, all related elements, like the wall opening or the surrounding trim, can automatically update. It can also automatically extract consistent drawings, reports, schedules, greatly improving efficiency and accuracy across all the design disciplines.
That sounds incredibly powerful.
Yeah.
How does BIM actually change the game in terms of design and collaboration, beyond just, making pretty 3D pictures?
Oh, it enables incredibly powerful analyses. You can run structural or thermal analysis directly from the model, simulating how the building will actually perform under different conditions before it's even built.
Wow, like virtual testing.
Exactly. It also assists with quantity takeoffs, scheduling, and procurement applications, generating precise lists of every single material needed. And crucially, it facilitates clash detection.
Clash detection. What's that?
Imagine bringing together the separate models from the architect, the structural engineer, the mechanical engineer. BIM automatically identifies where things conflict, where a duct might be trying to run straight through a structural beam, or a pipe is clashing with electrical conduit.
Finding problems before they happen on site.
Precisely. This early detection of these intersecting volumes from multiple models dramatically reduces costly errors and rework down the line. It saves millions and prevents huge schedule delays. It can even trigger automated design changes for simpler conflicts.
This is huge.
And moreover, the construction manager, the CM, plays a vital role in this design phase too. They provide proactive, not reactive, cost management.
Keeping an eye on the budget from day one.
Right, to reduce the need for redesigns later because things got too expensive. They establish a uniform cost estimating framework that's maintained across all project phases, ensuring financial oversight from the very earliest stages. That's invaluable.
It sounds like a truly dynamic process, this constant back and forth between the creative vision and the practical constraints.
It really is.
It almost echoes those historical debates in architecture, doesn't it? Like Louis Sullivan's famous idea, form ever follows function,
A foundational principle.
arguing that a building's purpose should dictate its design. But then you have Winston Churchill's equally potent counterpoint. We shape our buildings, and afterwards our buildings shape us.
Ah, yes, a great quote.
Which really highlights that evolving reciprocal relationship between design and how a space is ultimately used and experienced over time. It's never just a static thing. Buildings live and breathe with us.
Beautifully put. They absolutely do.
Okay, so the vision is taking shape, the team's being built, BIM is helping iron out all the design complexities. But none of that happens without money, right?
Correct. Money makes the world go round, especially in development.
So the next huge hurdle for any developer is securing the capital, the construction financing process. That's truly the lifeblood of any project. Without it, even the most brilliant vision just stays a vision on paper.
Absolutely. The project budget has to meticulously cover all the owner's costs. And that's way more than just the visible construction.
Like what?
Well, the initial land acquisition cost, legal fees, architect and engineering consultant fees, interest payments on loans during construction, marketing, sales costs, contingency funds, much more.
Wow, okay.
The construction loan itself is paramount. It provides the actual funds to build. However, getting those funds, especially for what might be seen as gradual change in neighborhoods that traditional lenders have often deemed hopeless or just too risky,
Yeah, that must be tough.
it can be incredibly challenging. There have been instances like in New York's past efforts to conserve some declining neighborhoods where entirely new loan authorities or complex public-private partnerships had to be created just to provide even a small amount for basic improvements.
So standard banks might just say no.
Often, yes. It really underscores how difficult it can be to get traditional financing for projects that don't fit that conventional high-profit, low-risk mold. And that often leaves underserved communities struggling to attract the investment they need.
And when it comes to estimating all those costs you mentioned, it sounds like there are just so many hidden factors that could trip up even experienced professionals. It's not just the bricks and mortar we see.
Indeed, estimating is far, far more than just adding up material and labor costs. A comprehensive estimate must include a whole host of costs that have nothing to do with the actual structure of the facility.
Such as?
Things like permits, supervision costs, scaffolding rental, temporary site facilities, freight for materials, performance bonds, liability insurance, sales tax on materials.
Yeah.
The list goes on.
Yeah.
If an estimator misses these, they might win a bid by being the lowest price, but they'll end up losing money on a project because their true costs are actually far higher.
Ouch. That's where you win the battle but lose the war.
Exactly. And this is where modern technology, again, offers a significant advantage. BIM's 5D cost management capabilities are revolutionary here.
5D. Okay, we had 3D modeling. 4D was adding time. What's 5D?
5D integrates the 3D model with time, that's the fourth key for scheduling, and cost, the fifth D for budgeting and financial tracking.
Got it. Cost is the fifth dimension.
Right. This allows for parametric and dynamic quantity takeoff for bills of materials. Basically, the model can automatically and precisely calculate the exact quantities of every single material needed.
No more manual counting.
Much less. Anyway, it leads to far more accurate estimates and, importantly, gives the human estimators more time for actual cost estimate analysis, thinking strategically about the numbers rather than just tedious manual counting.
So BIM makes the how much question far more reliable. But beyond the immediate project costs, a developer needs to think long-term, right? About the financial life of their assets. Which brings us to concepts like depreciation and amortization. What's the strategic insight there for a developer?
Okay, so the insight is that these aren't just boring accounting terms. They're actually powerful tools for long-term financial health and strategy.
Right.
Depreciation is the accounting method of allocating the cost of a tangible asset like the building itself over its useful life. It reflects its gradual loss in value over time due to wear and tear or just becoming outdated.
Okay.
For a developer, understanding depreciation is critical because it impacts taxes. It allows them to deduct a portion of the asset's value each year, which reduces their taxable income. Mismanaged depreciation, and you're leaving tax savings on the table, savings that could fund future projects or boost profitability.
So it's a tax shield, essentially.
In a way, yes. Amortization, on the other hand, is generally used for intangible assets, like the cost of obtaining a loan or a patent, Or, in a construction context, it can sometimes refer to the practice of charging science an amount to build up a fund for purchasing new equipment in the future.
Planning for replacement.
It's exactly. It's about ensuring the contractor, and by extension the developer's project, can renew its asset fleet and stay competitive. So a deep understanding of this duo depreciation and amortization gives them a competitive edge. It's proactive financial engineering, not just reactive accounting after the fact.
It's clear that financial savvy is absolutely non-negotiable. But even with all the money lined up, the developer still has to navigate that dense regulatory framework, right? Things like zoning, building codes, and increasingly sustainability mandates. It sounds like they need to be part legal scholar, part builder.
It often feels that way.
Precisely.
The developer must navigate the labyrinth of zoning and entitlements, making sure their vision aligns not just with local rules, but often state and national regulations too.
And building codes.
Oh, building codes are a massive body of rules. They're generally designed with a general philosophy to offset active fire protection measures, like sprinklers, with passive measures, like fire-rated walls, and to hold egress paths, meaning exits, to higher standards.
Safety first.
Absolutely.
Yeah.
This translates into very specific rules for everything. The exact height clearance needed for a mezzanine level minimum 7 feet clear headroom. How many exits you need for a given number of occupants, it's not just a suggestion, it's codified.
For example.
For example, egress paths generally require 2 separate means of exit for occupant loads between 1 and 500 people, though there are some exceptions for smaller spaces. Automatic sprinkler systems are often mandated for large occupancies, like fire areas greater than 12,000 square feet for certain building types, like Group E for schools or Group M for stores.
It's a very specific requirement.
Very. Missing one seemingly small detail can lead to massive delays or extremely costly redesigns. Even something like ventilation for today's relatively airtight modern homes often requires mechanical systems per the International Energy Conservation Code, because houses are built so tight for energy efficiency they don't breathe naturally enough.
Right. Sealing them up for energy means you have to actively manage air quality. And sustainability, that's definitely not just a nice to have anymore, is it? It seems like it's becoming fundamental to the regulatory and design process. It must influence everything from material choices to energy systems.
Not at all, just nice to have. Sustainability is a rapidly growing and often legally mandated component of development now. Developers work closely with owners to establish specific sustainability goals and objectives, often involving registration with the U.S. Green Building Council, USGBC, for LEED certification.
LEED Day, right. Leadership in Energy and Environmental Design.
That's the one. However, green building assessments themselves can be complex, and sometimes they lead to unexpected outcomes or debates.
Oh, like what?
Well, take the Bank of America Tower in New York. It was awarded a prestigious LEED Platinum rating, the highest level. Yet it initially faced criticism because studies suggested it consumed more energy per square foot than the much older 80-year-old Empire State Building.
Wow, really? How does that happen?
It highlighted the crucial challenge of normalizing energy performance. You have to compare apples to apples. A building with 247 trading floors, like the Bank of America Tower, has fundamentally different energy demands than a standard office building operating maybe 12 hours a day.
Ah, okay. Different uses, different energy needs.
Exactly. Newer versions of ELD have since addressed this better, requiring minimum energy performance improvements relative to baseline buildings for all certified projects. The focus is shifting more towards actual measured performance over the building's life, rather than just points for design intentions.
So it's not just about getting the green sticker on the door, it's about actual measurable performance. And throughout all these complex financial and regulatory hurdles, risk management must be a constant looming concern for developers. It sounds like the developer's constantly playing chess against a whole host of potential problems.
It's absolutely central to everything they do. Risk management is a systematic process. It's about methodically addressing risk and working to lessen the impact of bad things happening, while also, importantly, identifying opportunities to maybe reduce costs, shorten schedules, or improve quality.
So defense and offense.
Exactly. Think of it like a seasoned sea captain navigating treacherous waters. They don't just hope for the best. They identify every potential storm, analyze its likely intensity, and then plan their route to either avoid it or prepare the ship for its impact. A developer does the exact same thing for a building project.
Okay.
This process involves risk identification, risk analysis, and risk management across all project phases. right from pre-design, where they review initial design concepts, potential external challenges, funding strategies, community impact, all the way through construction and even operation.
Constant vigilance.
Constant. Developers, often working very closely with a construction manager, rigorously review contracts, specifically looking for potential risks and liabilities and legal requirements. For instance, the CM's contract with the owner must clearly define the scope of such services, like providing an overall job site safety program, and include compensation to cover the CM's cost for appropriate liability protection.
Covering all the bases.
It's about ensuring everyone's responsibilities and protections are clearly spelled out. Who's responsible if X happens? Who carries the insurance for Y?
That makes perfect sense. You want total clarity, right down to who's covering potential pitfalls. What about the different ways these partnerships are actually structured? Because it's rarely just a single company doing everything, is it?
That's a great point. No, it's usually a team effort. Contract types vary significantly depending on the project's complexity and how the parties want to allocate risk.
Like what kind?
Well, you have agency construction management, or agency CM. Here, the CM acts purely as the owner's agent, providing expertise and advice, almost like a trusted consultant. The owner holds all the financial risk.
Okay, CM as advisor.
Right. Then there's at-risk construction management, or CM at risk. In this model, the CM essentially acts more like the general contractor. They commit to delivering the project within a guaranteed maximum price, or GMP.
So they take on more risk.
Exactly. They take on more of that financial risk, which can offer greater cost certainty to the owner, but it usually comes with a higher fee for the CM to compensate them for taking on that added risk.
Makes sense.
And of course, joint ventures are very common in construction. That's where two or more companies combine resources and expertise for a specific project. But it's important to remember legally that a joint venture has no legal existence. It is just a name, a description of an undertaking.
So it's a partnership structure, not a separate legal entity itself.
Correct. It highlights the often collaborative yet legally distinct nature of these complex partnerships that underpin major projects. It allows companies to pool resources and share expertise without fully merging.
All right, so the developer has done it. They've identified the opportunity, secured the site, done massive due diligence, gotten the designs locked in, navigated all the legal and financial mazes, and assembled their team. Now, finally, it's time for the rubber to meet the road, the actual construction phase.
The exciting part.
This is where the vision truly comes to life, brick by metaphorical brick, and it requires incredible orchestration, like conducting that massive orchestra where every single instrument has to play perfectly in sync.
Indeed. The overarching goal in this phase is really to expedite and improve the efficiency of the construction process through professional planning and execution of project activities, and all while meticulously meeting those crucial scope, cost, quality, and time requirements.
The iron triangle plus quality.
Exactly. The construction manager is absolutely central here. They provide coordination and leadership of the individual professionals and contractors. They establish clear communication procedures. They organize all sorts of meetings, pre-construction meetings, regular progress meetings, special meetings for specific issues, basically keeping everyone aligned and informed. Their job is to keep all those moving parts coordinated and, hopefully, on schedule.
So it's a huge coordination effort. What's the approach to leadership in such a dynamic, often high-pressure environment? I mean, you could have hundreds or even thousands of people involved on a big project.
Yeah, it's not just about giving orders from the top down. Project team members are really encouraged to motivate, influence, coach, and grow, regardless of their specific role on the project.
Interesting.
This often involves what's called servant leadership. It's a style that emphasizes understanding and addressing the team's needs first to enable them to perform at their highest level rather than just issuing directives.
Supporting the team to succeed.
Precisely. Also critical are work structuring decisions. Essentially, work structuring is about strategically deciding how the massive construction project gets broken down into manageable pieces and assigned to different specialist contractors or teams.
Okay.
It's about optimizing the flow of work between different groups, say the concrete team and the plumbers installing pipes in the slab to avoid bottlenecks and keep everyone working efficiently. It's about designing the production system, not just following old habits or letting contracts dictate the entire workflow. Ideally, it aims to optimize the entire production process on site.
Thinking about the whole system.
Exactly. And modern construction also leverages tools like 4D schedules, which we touched on briefly. These dynamically link the project's critical path method, or CPM, schedule activities directly to the 3D objects in the BIM model.
And for our listeners, could you just quickly recap what the critical path method is and why linking it to BIM is so critical for a 4D schedule?
Absolutely. The critical path method, CPM, is basically identifying the longest sequence of dependent tasks in a project that must be completed on time for the entire project to finish on schedule. Any delay to a task on that critical path directly delays the whole project completion date.
Okay, the sequence that dictates the minimum project duration.
Precisely. So linking these CPM schedule activities to the 3D objects in a BIM model, that's what creates the 4D schedule. It results in a graphically rich and animated representation of the planned construction sequence set against time.
So you can actually watch it being built virtually.
You literally can. You can watch a simulation of the building being constructed over time on your screen, identifying potential conflicts, logistical issues, or delays before they happen out on the actual site. It's an incredibly powerful visual tool for planning, communication, and definitely for risk mitigation.
That dynamic scheduling sounds like a total game changer for visualizing progress and heading off problems. Now, let's talk about the physical stuff. The actual construction methods and materials that make this vision solid. What are some of the fundamental choices and considerations here?
Well, the choice of materials and methods is crucial, obviously. It's always a balance between cost, durability, performance, speed of construction, and increasingly sustainability.
Right.
For example, wood-light frame construction, standard stick framing for houses, despite being potentially prone to burning, decay, or dimensional changes, if not properly detailed and maintained, remains the least expensive form of durable construction. And it's still the dominant system in North America, particularly for residential buildings.
Still king for houses.
Pretty much. And it's fascinating, its origins. Modern American house construction, as we mostly know it, likely began way back in 1832. A guy named George Snow built a warehouse in Chicago using thin lengths of wood placed close together, fastening the pieces to each other with nails.
Instead of heavy timbers.
Exactly. It was a significant departure from traditional heavy post and beam framing. Much faster, used less wood, needed less skilled labor. Then, of course, you have concrete, a real workhorse material that involves specific compositions of cement, aggregates, water, careful curing to achieve maximum strength, and usually reinforcement with steel rebar.
And the forms to shape it.
Right. The formwork for columns and walls can be custom built on site for unique shapes. Or increasingly, it's prefabricated from steel or aluminum and designed to be reused many times for efficiency, especially on large-scale commercial builds.
And what about building parts in factories?
Yeah, panelized construction where building components like entire wall sections or roof trusses are manufactured in a controlled factory environment, year-round, protected from the weather. That's almost as old as the wood-light frame itself. It's not a new idea, but offers big advantages in quality control and speed of assembly once the components get to the site.
So it's a real mix of time-tested methods, advanced materials like engineered concrete mixes, and factory-built components all coming together. How do developers ensure quality throughout this complex, multifaceted process on site?
Quality management processes are absolutely essential. They had to be woven through everything. They're designed to produce deliverables and outcomes that meet project objectives and, critically, meet stakeholder expectations.
Preventing problems.
Exactly. The main goal is preventing defects from occurring in the first place, or at least identifying them very early to avoid costly rework later on. This could involve everything from inspecting materials as they arrive on site, to performing in-process checks during installation, to final testing.
And the finishes matter too, right? The stuff we actually see and touch.
Oh, immensely. Details matter hugely for the final product. Materials like gypsum board, which most people know as drywall, offer good fire resistance and dimensional stability, which is why it's a standard for interior walls and ceilings. But even with something seemingly simple like plaster ceilings, for instance, you need control joints at least every 30 feet in each direction.
Why is that?
To relieve natural shrinkage and stress as the plaster dries and the building moves slightly over time. Without them, you get those unsightly cracks appearing in large plastered areas. These seemingly small details are vital for both the immediate look, the long-term functionality, and the overall perceived quality and longevity of the building.
And once all the hammering, wiring, painting, and finishing are finally done, what happens then? It's not just, here are the keys and the developer walks away. There's this whole post-construction phase that sounds just as critical.
You're absolutely right. It doesn't end at handover. This phase follows substantial completion, meaning the building is basically ready for use, and it's all about ensuring the building is truly ready for its intended operation, and that the owner has everything they need.
Like what?
A key deliverable here is the as-built drawings, sometimes called record drawings. These documents show the actual installation of the building systems and components, reflecting any changes or deviations made during construction from the original plans. This is vital information for future maintenance, repairs, or renovations.
Knowing what's actually in the walls.
Exactly. And crucially, there's building commissioning. This is a quality assurance process that provides confidence that the facility will actually function as it was designed to. It goes way beyond just a simple inspection.
Oh, so.
Commissioning typically involves two main parts. First, installation inspection, which checks that equipment is installed correctly according to the drawings and specifications before you even turn it on. Second, performance testing, which verifies that the system's HVAC, lighting controls, security systems actually operate correctly under various load conditions. Does the AC cool properly when it's hot outside? Do the lights dim as programmed?
Making sure everything works as intended.
Precisely. Ensuring the building performs as designed right from day one.
And beyond just ensuring that immediate functionality, I understand developers are increasingly looking at the much longer view now, the entire life cycle of a building, not just its construction and initial operation.
That's right. There's a growing focus on the full life cycle of a building. That means thinking about everything from the extraction and processing of raw materials to the fabrication of components to the building's use phase, energy, water, maintenance, and ultimately its end-of-life options. Can it be deconstructed for reuse? Can materials be recycled? Or does it just become waste?
Cradle to grave, or cradle to cradle.
Ideally, cradle to cradle. There's a strong push toward more sustainable practices, often guided by principles like the cardinal rules for a closed-loop building materials strategy.
What are those?
They emphasize things like deconstructibility, designing buildings so they can be easily taken apart rather than demolished into rubble, disassemblability of components, recyclability of materials, and using harmless materials that won't leach toxins into the environment during use or disposal.
Aiming for a circular economy.
Exactly. The ultimate goal is to dramatically reduce the need to extract virgin resources, increase the reuse and recycling of building materials, and minimize emissions and waste that affect both ecosystems and human health. It's about striving for a much more circular economy in the construction sector, where waste is designed out and resources are kept in use for as long as possible.
So we've covered this incredible journey from that first spark of an idea all the way to a finished building that's commissioned and hopefully ready for a long, useful life. Now let's zoom back in on the developer themselves. What are the qualities, the skills, the tools that truly make them successful in this incredibly demanding field? At the top of that list surely has to be market acumen, that deep understanding of the landscape, both what it is now and where it might be heading.
Absolutely essential. Non-negotiable. This requires a really keen eye for those opportunities to produce revenue we talked about earlier. And just as importantly, a realistic, almost brutally honest view of current market conditions. Again, think of George Washington. They must see things as they were and not as he would wish them to be.
Grounded in reality.
Totally. And the modern urban environment adds another layer of complexity. It's increasingly a hybrid space at the intersection of physical and virtual. We have these pervasive broadband, fiber optic, and wireless telecommunications grids, creating a profusion of urban big data.
Urban big data.
Yeah. Data on everything: traffic patterns, public transit usage, retail foot traffic patterns, energy consumption patterns, even social media sentiment about a particular neighborhood. Successful developers need to understand how this data can potentially optimize the entire system, informing decisions from where to locate specific amenities with the building to planning more efficient waste disposal routes for a whole development.
Wow.
This also means understanding how social systems have struggled historically to keep pace with accelerating technology. Technology often advances at exponential rates, while people and institutions tend to change much more slowly, more linearly.
That's a fascinating and provocative idea, our cities as these hybrid physical and virtual spaces. What's maybe the biggest insight a developer needs to grasp about this convergence? Is it just about sticking smart tech into buildings? Or is it something deeper about how people experience space now, what they demand from it? And how does that challenge of social systems keeping pace with tech actually affect their strategy? Are they trying to predict the next big tech disruption? Or are they focused on designing adaptable buildings?
That's the million-dollar question, isn't it? The key insight, I think, is that connectivity and digital infrastructure are now almost as fundamental to a building's value proposition as, say, reliable plumbing or electricity used to be.
Table stakes now.
Pretty much. Developers who understand how urban big data can optimize their designs, enhance the user experience for tenants or residents, maybe even predict future demand patterns, and certainly manage a building's operations more efficiently. Those are the ones who will likely thrive. It's about building for a digitally native future, not just a physical present. And regarding that social tech gap, the best developers aren't just reacting to the latest tech fad. They're trying to anticipate. We've learned lessons from past overspecificity in design. Think about the smart buildings of the 1980s that tried to hardwire every conceivable tech solution into the walls.
Right, I remember those.
They often failed because sophisticated users actually preferred custom solutions they could control themselves, rather than a built-in one-size-fits-all system that quickly became outdated.
Yeah, tech moves too fast.
Exactly. So this highlights the critical need for adaptability, for flexible infrastructure within buildings, rather than simply optimizing around today's potentially transient trends. The real challenge is building future-proof structures, or maybe future-ready is a better term, in a world of exponential tech change. Designing buildings that can evolve with the occupants' needs and with technological advancements, rather than becoming obsolete in just a few years.
So a focus on flexibility and adaptability, not rigid, pre-programmed smartness.
Okay. Beyond that market intelligence and tech savviness, what about the personal skills? The ones that truly set developers apart? I'm thinking about the art of the deal, that constant negotiation and navigation required in such a complex field with so many stakeholders.
Oh, sharp negotiation skills are
Yeah.
absolutely essential. It's almost a superpower in this industry.
A superpower, huh?
Seriously. And it's not just about financial negotiation, getting the best price on land or the lowest construction bid, though that's important. It's also crucially about navigating intricate political landscapes, dealing effectively with community groups who might oppose a project, and managing the often competing expectations of investors.
The people skills. Huge. You look at historical figures like Robert Moses in New York. Whatever you think of his legacy, he demonstrated an extraordinary, if often controversial, capacity to manipulate men, as his biographer put it, and leverage political power to realize his vast public works dreams. Sometimes it seemed his motivation shifted from the work itself to the raw pursuit and exercise of power.
A cautionary tale, maybe?
Perhaps. But he achieved incredible feats by mastering how to play the political game. On a more day-to-day level, developers are also constantly dealing with unforeseen issues that pop up during construction, like change orders, requests for changes initiated by the architect or contractor.
Right, things always change.
Always. These require careful management to ensure they're properly authorized, fairly priced, and that appropriate time extensions are granted if needed. It prevents scope creep, budget overruns, or schedule delays. It's a constant negotiation, really, both big-picture strategic stuff and tiny granular details. It requires immense patience and persuasive ability.
That really underscores the human element involved, doesn't it? The sheer force of will and interpersonal skill required. And given all these challenges, the financial risks, the regulations, the negotiations, the construction hurdles, it must take an incredible amount of grit and resilience to see these multi-year, multi-million-dollar projects through to completion.
Unwavering persistence is absolutely a hallmark of successful developers.
Right.
Maybe the most important trait of all.
Really?
I think so. Projects are rarely, if ever, straightforward. Overcoming obstacles, big and small, is a constant. As Samuel C. Florman, a renowned engineer and writer, put it, the existential pleasure in engineering, and I'd say development too, comes partly from that immersion in the material world, but also from engaging in activity which is often mundane. It reflects the persistent, sometimes unglamorous day-to-day effort required, the daily grind of just solving problems.
Keeping going when things get tough.
Exactly. And learning from plan failures is also key, fostering what some call coping behavior at the edge of control. Processes like DCAP, which stands for Detect, Correct, Analyze, Prevent, are crucial here.
DCP. Explain that.
Okay, imagine a pipe bursts on-site during construction. Detect is obviously noticing the leak. Correct is fixing that specific burst pipe right now. But the real learning comes from analyzing, asking why did it burst? Was it a faulty batch of pipes from the supplier? Was it an installation error by the crew? Was the pressure too high? And prevent is then taking action based on that analysis, maybe changing your procurement specs, improving installation training, adjusting system pressure to ensure it doesn't happen again with any pipe on any future project.
So it's about institutional learning, not just fixing the one problem.
Precisely. Learning and continuous improvement. Ultimately, as Donella Meadows wrote about systems thinking, while the future can't be predicted, It can be envisioned and brought lovingly into being. Systems can't be controlled, but they can be designed and redesigned. That really encapsulates the persistent yet adaptable, forward-looking spirit required of a good developer.
And as we've touched on throughout this deep dive, technology isn't just, a background player anymore. It's become a central part of the developer's toolkit, providing a real digital edge that fundamentally transforms how they operate.
That's absolutely right. BIM, as we discussed, remains central. It functions as that indispensable digital database, supporting diverse analyses, from structural integrity checks to energy performance modeling.
Right.
The critical aspect enabling this is interoperability, the ability for different BIM platforms to seamlessly exchange data with various specialized analysis tools for structural calculations, thermal modeling, quantity takeoff, scheduling, and so on. This is why explicit exchange standards, like IFC industry foundation classes, are becoming increasingly recognized and vital across the industry.
So different software can talk to each other.
Exactly. They ensure that different software programs from different vendors can communicate effectively, preventing data loss or corruption and enhancing collaboration between all the different specialists involved in a project. This whole approach, integrating data and tools, reflects a broader trend of tailoring project management approaches to suit the unique objectives and the environmental complexities of each specific project. It ensures the flexibility needed for consistently positive outcomes. The digital edge isn't just about having the latest software, it's about intelligently integrating these tools into a flexible, adaptable, and data-driven system that supports the developer's vision from the initial concept all the way through to completion and operation. Hashtag outro.
And that brings us toward the end of our deep dive into the world of the real estate developer. We've journeyed through their pivotal, often kind of unsung role as the initiators, the orchestrators, the ultimate clients driving our built environment.
The starting point.
Yeah, from that initial spark of identifying a market opportunity to navigating that complex dance of financing and regulations, and finally to assembling the diverse teams and leveraging powerful technologies that bring designs to life. The developer's journey is clearly one of immense risk, but also profound vision and just relentless execution.
It really is, and we've seen how their key skills, the sharp market insight, the adept negotiation, that unwavering persistence are constantly evolving and now powerfully aided by sophisticated tools like building information modeling and the whole burgeoning field of urban data analytics. They truly are the unseen hands shaping the skylines, the communities, and the neighborhoods we inhabit and experience every single day.
And that's why this matters so much to you, our listener. For any architect, contractor, engineer, urban planner, or frankly, just anyone involved in shaping the spaces around us, understanding the developer's mindset, understanding their motivations, and the intricate processes they manage, it's not just beneficial, it's really a critical best practice.
Absolutely.
It's about understanding your ultimate client, if you're in the industry, and the powerful economic and social forces that truly drive development in our world. It's about recognizing the starting point of nearly every single building project you see.
Well said. And as a final provocative thought for everyone to mull over, consider this quote from the philosopher Hannah Arendt. She suggested that the reality and reliability of the human world rest primarily on the fact that we are surrounded by things more permanent than the activity by which they were produced, and potentially even more permanent than the lives of their authors.
Things outlasting their creators.
Exactly. So, as developers continue to identify these sometimes fleeting opportunities and orchestrate these incredibly complex projects, what responsibility do we all share as builders, as designers, as citizens in ensuring that these creations, these permanent additions to our world, contribute to a built environment that is not just economically viable for a time, but also truly enduring, maybe even beautiful, and certainly valuable for generations yet to come?
That's a great question to leave us with. It's something to definitely ponder on your next walk through the city as you look up at the structures around you and maybe think a little differently about how they came to be.